Right, I'm having a bit of a crazy headache, but what I want to talk about, because I can't find anything online that talks about a second. How's a second really measured? They talk about the cesium atom and it oscillates. The cesium atom doesn't just naturally oscillate, you've got to pass the right frequency through it. So I want to keep this real simple, because the words sound complex, like hyperfine. That's such a beautiful term. The hyperfine transition and Bohr's magneton. That's it. They're not too complicated to understand and vision. So let's talk about it. If you pass a frequency, an electromagnetic frequency, through a cesium atom, we can't work out exactly what 9.2 billion oscillations is a second, but if we can pass 9 gigahertz, 9.4 gigahertz through a cesium atom, at some point, when it hits exactly 9.192 gigahertz, an EM wave is given off by the cesium atom. That's how we measure a second. Now, how does that happen? Why can't you just pass an electric field through the cesium atom? Because we need the magnetic component of the electromagnetic field. So when we pass a photon or an EM field through an atom or anywhere, we've got an electric component, and when we've got a moving electric component, we've got a magnetic component. Now that magnetic component, don't let me lose you here, that magnetic component, when it hits the cesium atom, instead of transitioning an electron from one orbital to another, which is how we see stuff, gives off a photon, what happens is, one of the orbitals, when the electron spins, which is the magnetic moment, because spin creates magnetism, when the electron's magnetic moment spins, when it aligns with the proton's magnetic moment, that's what we call the hyperfine transition. That's it. Proton, magnetic moment, electron, magnetic moment, you can picture that, right? When they align, that is what we call the hyperfine transition. And how often does the hyperfine transition happen? Millions of times a second, right? Wrong. The hyperfine transition happens once every 2, 3, 4 million years, unless you force it. So we force it with the cesium atom to get our second. So we care about the magnetic component of the EM field. When it hits around 9.2, when it gives something off a photon, we know that's 9.2 gigahertz. Now, that hyperfine transition is just happening on one orbital. It's not transitioning, it's happening on one orbital when the two things align and it gives off a photon or an electromagnetic wave. That photon, we've got to be careful to go from mechanical to quantum stuff here, that photon oscillates at 9 billion cycles a second, 9,192,000,000 and something cycles a second, and that is exactly how we count a second. It's 9.1 billion oscillations, or 9.2, sorry if I round it up, 9.2 billion oscillations a second of that photon of light is how we measure a cesium atom. And that is just incredibly cool, right? All the terminology is not scary, it's cool. Hyperfine, Bohr's magneton. I mean, you don't have to do the maths. You can just think and visualize. I just love visualizing this stuff in colors and understanding how it looks in my own way. Everyone's gonna have their own way of understanding this. But that is fundamentally how we measure a second. Fundamentally how we see light is when you have an electron transition from one orbital to another, it gives off a photon. Those two transitions, hyperfine and electron transition, are just fundamental to understanding everything around. Time, color, space, everything. It's amazing. So yeah, when I see these videos of people saying that, an oscillatory, a cesium atom vibrates 9.2 billion cycles a second, it's not quite that simple, but it's not even that complex. So I hope you found that useful.